So in the examples that we did at the beginning of class, we solved for either x or we solved for theta. But sometimes a question is going to ask you to solve the entire triangle, which means they want you to find all the angles and all the sides. So to do that, we're going to look at everything we know about triangles so far. So for example, if you know two of the angles, you know that all three angles in the triangle add up to 180 degrees. So then you could find the third angle easily. Once you know two angles, the easiest way to find the third one is you know that they all have to add up to 180 degrees. If you know two sides, you can use a squared plus b squared equals c squared to find the other side. This you've done in the past, and this works with any right-angled triangle, but only right-angled triangles. But for what we're going to do for trigonometry in grade 10, we're only going to have right-angled triangles, or we'll have to make right-angled triangles to make it work. Anything else, you'll have to use SOHCAHTOA. So you use the right definition based on the sides that you know. And sometimes you have choice in a question. You have more options, so you could use more than one definition. If you have more options, it doesn't matter which definition you use, they will all give you the same answer. So this is what a question will look like. Solve this triangle. So can you see that there are two angles we don't know and one side we don't know? And you have options. There's many ways that you could start this. You could start with SOHCAHTOA, or you could start with a squared plus b squared equals c squared. Either would be fine. All right. Let's pick one. Zaya, which one would you like to do? A squared plus b squared equals c squared, or would you like to start with SOHCAHTOA? Okay. So if we started with a squared plus b squared equals c squared, we would be solving for, and since this is labeled, I'm going to put a little m there. And I'm also going to, the only thing I labeled is my hypotenuse. But do you see that little m is your hypotenuse? That's important in a squared plus b squared equals c squared. Because which letter is the hypotenuse in a squared plus b squared equals c squared? It's the c. Now technically the letters are arbitrary here, because we're actually going to use 7 squared plus 11 squared equals m squared. We can write down a squared plus b squared equals c squared just for the idea in our head. But in this question, the letters are different than A, B, and C. But it's important that we're solving for the hypotenuse, so that's on this side. It's an easy mistake to make with a squared plus b squared equals c squared is put the numbers in the wrong spot. Go to our calculator. This will be 49 plus 121. But if you type 7 squared plus 11 squared all the way into your calculator right away, you see that you would get 170. And so m, if you like exact numbers, is the square root of 170. If you like decimals, and the question does say to round to the nearest tenth, so we'll write down decimals here. And we're going to make a little note here. I'm going to make a little note about exact numbers and rounded numbers. Because if you use a rounded number early in calculations to find something else, sometimes rounding early can cause your answer to be wrong in the end. Sometimes you get lucky and it doesn't matter, but sometimes it can cause you problems later on. Okay? So I wrote exact there. If I was doing any calculations and I wanted to use this 13, I would actually use the square root of 170 instead to make sure I don't round early. Okay? There's other ways to avoid rounding errors in this question as well, but we found one thing. So we chose to do a squared plus b squared equals c squared first, and we found the square root of 170, or 13.0 for n. Next, we need to find an angle. And we can actually, it doesn't matter which one you find first, they both work. So, Megan, K or N, doesn't matter. Which one would you like to do? K. Now, if we're solving for angle K, and I'll do this in green now, we have a lot of options with SOHCAHTOA. Because if I look at SOHCAHTOA, for angle K, you see that you know the adjacent side, you know the opposite side, and you know the hypotenuse. We know all three sides. That means you're allowed to use any definition, either sine, cosine, or tangent. However, I would recommend one over the other two for this reason. Okay? I would recommend using tangent because it uses the opposite side and the adjacent side. What might be some reasons I'd want to avoid using the hypotenuse? It's not a whole number, like we rounded early, so if you use the 13, you might make a mistake. It's also the one we solved for. In a question, they gave us the 7 and the 11. I can guarantee that those are the right numbers because that was given to us. I can't guarantee that I didn't make a silly mistake with the blue numbers, right? I can tell you we didn't. It is the right number. It's perfectly fine, but there's a chance. And if you use a mistake you used earlier to find something else, your next number is going to be off as well. So I would use tangent for the green one, and I would go tan of angle K is equal to the opposite side, that's the 11 for angle K, and the adjacent is 7. So then I can find angle K by going tan inverse of 11 over 7. So to get rid of the tan, I have to do tan inverse on both sides. I'll turn my calculator on. $57.5 because it wants to the nearest 10. And so on my triangle, I'm going to label it on my triangle as well. For these solving questions, labeling things on your triangle as you find them is important because you will determine, am I done or not? Once everything is labeled, you're done. Can you see we're not quite done? We've labeled the sides. All the sides are done, but not all the angles are done. I'm terribly curious in this one, okay, if you decided to use sine or cosine, would it give us the right number rounded to the decimal place, or would the rounding go up? So I'm going to check. First of all, I want to show you that had you decided to use sine or cosine, if you had used cosine, you would do cos inverse of the adjacent side, which was 7, over the hypotenuse. Actually use the fraction button. 7 over the hypotenuse, and if we wrote out the exact value, it was the square root of 170, right? So if I had used cos and I used the exact numbers, look at the answer. All the decimals are identical. So it wouldn't have mattered had we chose tangent or cosine. And in fact, the numbers are identical also tells me that my hypotenuse has to be right. I told you it had to be right. Now we've double checked it. But my question is, had I used the rounded number, how much of a difference did it make? I'll even put the point 0, even though it doesn't matter. I could just write 13. If I had used how much of a difference does it make? Wow, you would have lost a half a mark. See how it comes at a 57.4? And it was to one decimal place. The answer is 57.5. So I'd be forced to say, rounding early, take off a half a mark on a quiz or a test. So rounding early can cause our final answer to be off. And then for the very last angle, which we need to solve for, that's angle M. That's the only thing we haven't found. Well, now you can, the easiest way to find it is that all the angles add up to 180 degrees. So if you do that, you'll get 32.5 degrees. And that's what solving a triangle is all about. Okay? There are people that want to only use SOHCAHTOA, right? You just got introduced to SOHCAHTOA, you fell in love with SOHCAHTOA. You could use SOHCAHTOA to find the angles. And then once you have an angle, you could use it also to find the hypotenuse. Again, the danger is rounding early. So if you use SOHCAHTOA and then use an angle that you rounded early, you have to make sure you use all the decimal places from your calculator. Okay. Another one. Solve this entire triangle. First of all, last time we chose a squared plus b squared equals c squared first. Can you see in this triangle, you can't use a squared plus b squared equals c squared first, because you only know one side. Can you see that finding the angle, the other angle, is probably the easiest thing to do? I can find angle J super easy because it has to add up to 180 degrees. Does 51 work? Does that add up to 180? Yes. And in right angle triangles, does anybody use the shortcut that these two have to add up to 90 in your head? Because you already know this is 90. So the other two have to add up to 90. So that would be the easiest thing to solve for. But now, and you have, again, some choice. You could either solve for little g or for little j. I'll color code them. Let's do little g in green, and let's do little j in purple. Which one do you want to solve for first? All right. Danny, J or G? G. So again, if you're solving for G, you could use the 39 degrees or the 51 degrees. I would probably choose the 39 because it was given to me. So based on the 39, I'm going to label my hypotenuse because we always know where our hypotenuse is, and it's on the bottom, opposite the 90. So in SOHCAHTOA, we either have to use sine or cosine. If I'm using the 39 degrees, the opposite side is the 9. So I write out my definition. Sine of 39 degrees. Opposite side is 9 over, I'll make my G fancy so I don't get it confused with a 9. You multiply both sides by G. You divide both sides by sine of 39. If that step makes sense to you, perfect. If not, you should show your work where first of all you're multiplying both sides by G. Cancel the G off the bottom. Then you're dividing both sides by sine of 39. That would get rid of the sine of 39, and that gets G by itself, and you're left with 9 divided by the sine of 39. We go to our calculator. $14.3. And there's units this time. So I make sure that I include my units. Now the last thing that we have to find is J. And there are tons of options for J. To find side J, you could use a squared plus b squared equals c squared, because you know two sides. You could use sine, cosine, or tangent, because you know everything except for J. I'd like you to think about those. Of all the options that are there, there's only one option that uses the numbers that were given to us. And that would be, in my opinion, the best option for not making a mistake with rounding. So if I want to use the angle and the opposite side, and I want to find the adjacent side, I'm going to say that your best option is to use tangent, the definition of tangent, because it would use the opposite side, which is 9, divided by the adjacent side, which is J. All the other options will give you the right number as long as you don't round early. But this one, you don't have to worry about rounding early because you're using the values that were given to you. So technically, this is the best option. Again, you can go right to this step. But if you want to show your work, we multiply both sides by J. That simplified the J. Then we divided both sides by tan of 39. And that would get J by itself. But I'm happy if you just write the purple, if you're okay with that. And then we go to our calculator. $11.1. I look at my triangle. Everything is labeled on my triangle, so now I know that I'm done. Just for fun, I'm curious if I use a squared plus b squared, so you don't have to write this down, so we're done. But if I did use a squared plus b squared equals c squared to find J, first of all, this time we know the hypotenuse. That's 14.3. But there I'm using the rounded value. I know that one side is 9 squared, and I wanted to find J. So if I went to my calculator, and I did 14.3 squared minus 9 squared, pushed enter, and then did the square root of that answer, do I get 11.1 or is that my decimal off? Oh, in this case, you would have been okay. We rounded early, and it didn't matter. Probably because the 14.3, you see the 14.3 is really close to 14.3, because it's 14.30. If you wanted to use the 14.3, some calculators, like this calculator, lets me actually select all the decimal places, and then I can square that minus 9 squared. And instead of getting 123.49, I get 123.522. And we wanted our answer to match up with this 11.1140. Now when I square root, oops. Now when I square root, all of those decimal places are identical. But sometimes it's a little bit more work if you round early and have to figure out how many decimal places do I want to use. So in this case, using the tangent would be the easiest. This one's a little tricky. I'm going to get it started for you, and then you're going to figure out the rest. Okay? What's tricky in this one is this is not a right angle triangle. They tell us it's an isosceles triangle. So first of all, do we know what isosceles means? Two of the angles are equal, and two of the sides are equal. So on this one, you would already know this side is 8 meters, and you would know that this angle and this angle have to be the same. But unfortunately, we're not allowed to use SOHCAHTOA on this triangle because SOHCAHTOA and a squared plus b squared equals c squared only work with right angle triangles. So this is an example where you draw a straight line down to make a right angle. And this works with isosceles triangles only. When you draw that straight line down, you're going to split it up perfectly in half. So this side is going to be 6, and this side is going to be 6. And from here, you can now find, put a theta here, theta. So see if you can have that one solved for tomorrow.